So this time, we are going to tie two masses to a stick, M1 and M2. That stick is ultimately going to be balanced somewhere in between the two masses. We are going to call this distance D2. That's the distance between mass 1 and mass 2. And this distance up here we're going to call the distance to the center of gravity. How do we do this? Start with the same concept we had before. The torque applied on the left and the torque applied on the right have to be equal. That means that this mass on the left times the distance on the left is going to be that mass on the right times that distance on the right. Now we can plug some stuff in. What is the mass on the left? That's going to be M1. And the distance on the left is this distance we called the distance to the center of gravity. On this side, we've got mass 2, but the distance on the right is not clearly defined. We've got the distance from mass 1 to mass 2, and we've got this distance to the center of gravity. How are we going to find that distance over there? D2 minus the distance to the center of gravity. If you expand this out, like you do in your math class, distribute, and then move some stuff around, and then factor some stuff, and then divide a little bit, move some more stuff around, ultimately what you will get is that the distance to the center of gravity is equal to mass 2 times distance 2 divided by mass 1 plus mass 2. That is how you calculate the position of the center of gravity given only two objects at known low distances from each other. We are going to put, again, a mass of 150 grams over here on the left, and a mass of 50 grams over here on the right, and they are separated by a distance of 50 centimeters. Question is, where is the center of gravity that will allow these two things to balance? Here's a question for you. Will that center of gravity be closer to the 150 grams, closer to the 50 grams, or exactly in between? You're guessing that it's somewhere closer over there because there's more mass over there. Where exactly will it be? The distance to the center of gravity is equal to mass 2 times distance 2 divided by mass 1 plus mass 2. Mass 2 is 50. The distance is 50. Mass 1 is 150. Mass 2 is 50. That distance, 12.5, represents the distance from mass 1 to the center of gravity right here. That is our 12.5 centimeters. When there are three objects call them mass 1, mass 2, and mass 3, with distances d2, that's from mass 1 to mass 2, and distance d3, that's the distance from mass 1 to mass 3. So there will be a total torque on the left and a total torque on the right, and those two torques have to be balanced. And this distance we will call the distance to the center of gravity again. So mass 1 times the distance to the center of gravity will be equal to, the difference in this case is there are two objects to the right of the center of gravity, both of them applying a torque. Well, this one will be mass 2 times the same thing we had before. You've got this distance minus that distance, the distance from mass 1 to mass 2 minus the distance to the center of gravity, d2 minus dcg, g, plus the other, d3 minus d center of gravity. The distance to the center of gravity is equal to m2d2 plus m3d3 divided by m1 plus m2 plus m3. And just with these two calculations, can you see enough of a pattern for if you had 4 objects hanging from a stick? What would it look like if we had a 4th object up here, call it, of course, M4, with a distance down here, call it D4? What would our total formula look like? Plus M4 times D4, and then do all this other stuff, plus M4. $100 grams on the left, then 50 grams in the middle, and 150 grams on the right. This distance is 15 centimeters, and this distance is 50 centimeters. Question is, what is this distance right here, the distance to the center of gravity? So M2 D2 plus M3 D3 divided by all the masses put together. And 27.5.